Hello everyone, I am Anishu, a member of Team Embed Tech, and in this video, I'll be explaining you how you can create your own automated library management system. So, why is this project important? Traditional library management methods have proven to be inefficient and are often fraught with challenges, such as misplaced books, long queues, and difficulty in tracking transactions. To address these issues, we embarked on a mission to create a more efficient and automated, secure library management system. So, what will our proposed solution contain? The system will automate the process of book issuance and return, reducing manual interventions and minimizing errors. Automation should be efficient, reducing transaction times. The system should include anti-theft capabilities to prevent unauthorized book removal. Access to the system should be controlled and secure to safeguard library resources and data. The system should maintain a real-time database of book information, including the book details and user records. Database operations should be fast and accurate. The system should provide intuitive user interfaces for both students and library staff. Users should be able to manage the issuance and return of books with ease. The staff should manage the system effortlessly. Finally, the users should receive real-time notification about due dates and fines via emails. Notifications should be prompt and accurate. With all the overview and the context set, let's proceed with the project. The project will start with the hardware architecture. That is, knowing the basics of the hardware that are going to be used in the project and how they will be interacting with each other to perform the necessary tasks that are required to make the automated library management system. Here is a basic block diagram showing the hardware architecture of our system. As you can see, the IR sensors will be connected to the Raspberry Pi through the GPIO pins to send the data of the user to it. Similarly, the TFT display will be connected to the Raspberry Pi to show the prompts to the user to perform several actions that are required to either issue or return a book. Similarly, the Raspberry Pi camera module is used to detect the barcode and send the barcode data to the Raspberry Pi for processing. The Raspberry Pi is then connected to the MySQL database and interacts with it. It shares the data regarding the users and the books with the MySQL database and performs actions based on it. The Arduino Nano 33 IoT is connected to the MySQL database and is used to send the data regarding any new users to the database. It acts as an interface to add new users to the system. After you have completely assembled the system, your system should look something like this. You can see in the screen a basic prototype for the assembly of the automated library management system. As you can see, the Raspberry Pi camera module and the TFT display are placed on the top. The Raspberry Pi camera detects the barcode of the user and the book, while the TFT display shows a user-friendly GUI to the user, specifying what action to perform. The IR sensors are placed on the opposite ends, that is the right side and the left side, representing the book issuance and book return. The user can activate a task by simply waving his or her hand in front of the IR sensors. This will activate the system. Now, coming to the connections that are done to connect the hardwares to the Raspberry Pi. The IR sensors, the TFT display and the Raspberry Pi camera module are connected to the Raspberry Pi through the GPIO pins and the dedicated slot. Finally, coming to the Arduino Nano, I have simply used it as a remote to connect to the database and send the data regarding new users to the database. Now that you have a basic understanding of how your system should look like after assembling the hardware components, let's jump into the software section of the project. The software is going to be the core of this system. We will be dividing it into 3 parts to understand the software better. Now coming to the very first part, that is coding the Raspberry Pi. Before beginning the code for the actual automated library management system, first of all we will need to import several libraries that are necessary for this project. Coming at number 1 will be the OpenCV library for activating the video features, including the AI features that are needed for barcode detection by the Raspberry Pi camera module. Next, the PISBar library that is doing the actual decoding of the barcode. Next, the MySQL connector library that is used to connect the code to the MySQL database. Next, the SMTP library that is used to send the email notifications to the user. And finally, the tkinter library that is used to create the user-friendly GUI that prompts the user of what action to perform. Some of you may find that OpenCV is not compatible with Raspberry Pi camera module in Bullseye OS. Please transition to the Buster OS if you are facing this issue. I myself had to face this issue, that's why I know that it may happen with some users. Now that you have installed all the necessary libraries, you are ready to code. You can make your own code, or you can also get the entire code from the GitHub repository that I am sharing with this video. Now I will explain the basic setup of the code that I have written to give you a better understanding of what to do. Before beginning the code explanation, I must say that I can't go into the entire code in detail because there are more than 300 lines of code in this project. I will just go into the basics of how the system works to give you a clear picture of how you can set up your own code if needed. Or you can use the code that I have given in my GitHub repo as mentioned earlier. As you can see, I have imported several libraries to induce the different functionalities that are needed in the project. I have initialized different devices that are needed, such as the IR sensors and the Raspberry Pi camera module. I have also connected the code to the MySQL database, as you can see in the screen. These lines of code are basically connecting the code to the MySQL database. I have also created the port and server for the SMTP library that is used to send the email notifications to the user. Finally, I have initialized the tkinter library to create the GUI that you can see in the TFT display. Now I have defined multiple functions that are basically performing actions based on what task the user suggests through the IR sensors. As you can see here, the system activates as the user specifies an action by placing his hands in front of either the return section or the issue section. For this explanation, I will stick to the issue section. Let's say the user waves his hand in front of the issue IR. The system activates and asks the user for presenting a barcode for the book. If the barcode presented for the book is valid, then the system proceeds and asks the user for a user ID. Similarly, if the user ID is valid, then the system issues the book to the user. Once the issuance is successful, the TFT display shows a message to the user that the book has been issued. At the same time, the user will get an email from the system saying that the book has been issued. Similar to the book issuance, I have written the code for the book return. I have also added a fine section for the book return if the user is delaying in book return. You may go through the code for those sections yourself to understand the code better before utilizing it into your own system. Finally, once an action, say issuance of book, is completed, the system will automatically revert back to its initial state and wait for the user to wave his hand again. This gives the system the ability to continually check for new data and work without stopping until it is specified so. Now that we are done with the Raspberry Pi code, let's understand the Arduino code. Similar to the Raspberry Pi code, I have also uploaded the Arduino code in my GitHub repository. You can check it out if you need that too. Again, I won't go into the details of the code. I'll simply give a basic explanation of what's happening in the code. The user is basically connecting to the internet and then trying to connect to the database, that is the Raspberry Pi server. After the connection is successful, if the user gives the input that is valid, then the URL encode function is used to URL encode the strings. It replaces the characters that may have special meanings in the URL with their corresponding percent encoded values. Then the add user function is called with the extracted values from the user input. It checks if the client can connect to the specified server, that is the Raspberry Pi, and if the connection is successful, it prepares a URL string with the user's data encoded as parameters and sends the GET request to the server with constructor URL. Then it prints the response received from the server, which should include the debugging or status information. And finally, it closes the client connection when done. Overall, this code allows the Arduino device to connect to the Wi-Fi network and send user data to the server. The user data is expected to be in a specific format, and the server side PHP script should handle the data accordingly. With that, the Arduino code is also complete. Now coming to the final section, that is setting up the MySQL database. Coming to the setup of the MySQL database. To set up the MySQL database, you can directly use the Raspberry Pi itself. Firstly, simply install the MySQL or the MariaDB library, as it will allow you to access the MySQL database features through the Raspberry Pi itself. You can use the Raspberry Pi's default terminal to create the structure of the database. By creating the database and adding tables to it, you can do it all in the terminal itself. For the commands that you may need to create the database, you can take help directly from the MariaDB's datasheet that is available online. As you can see in the MariaDB datasheet, all the commands that are needed to create and connect to the server are given. You can use simple commands to create the database and interface with it. You can even add tables and alter them. You can even add values into the table directly from the Raspberry Pi's terminal using these commands. We don't really need to add the values into the database from here, as we will be doing that from the code itself and the Arduino. So you can simply create the tables that are required in the database and close the MariaDB setup. With that, you are ready and you have created your MySQL server. Now you can run the MySQL server that you have created using myphpAdmin in the Chrome or any browser of your choice. You simply need to use the IP of the Raspberry Pi and then use myphpAdmin to connect to the server using any browser of your choice. With that, you are also done with the setup of the database. You can now connect the database to other devices too. Finally, after completing the setup of your database, you are all set and your project is complete. You simply need to run the project and check for any potential errors. Here is a demo of how your system should work like. The system will initiate and then show a prompt to the user to ask for placing the hand to specify the task to perform. In our case, in this example, we will be performing the book issuance. As the user places his hands in front of the issue IR code, the system activates and moves further, and it asks for the barcode. If the barcode that is detected by the Raspberry Pi camera is valid, then the system proceeds and asks for the user ID. Similarly, if the user ID is valid, then the book is issued to the user. And a prompt message is shown to the user saying that the book is issued successfully. Similarly, a mail is also being sent to the user saying that the book has been issued successfully by the user. At the same time, the database has also changed and shows that the book has been issued to the user. Similar to how you have issued a book, you can simply return a book by placing the hand in the return IR and follow the prompts accordingly. And finally, you will receive an email saying the book has been returned if the return has been successful. Add a new user to the database. You need to connect your Arduino Nano to the computer that you are using to send the data to the database. After that, you simply need to connect the Arduino IDE to the Arduino, and in the terminal of the Arduino IDE, you need to write the information regarding the user that you want to add to the database. After sending the data to the database, you can see that the database refreshes and the new user has been added. Again, let's see if we can issue a new book to the new user added to the database. By following the similar steps that we have done to issue a book, we can see that now we can add a new book to the new user that we have added in the database. The new user also gets the email. Now let's see how we can return a book to the library with find. To do that, we will be manually changing the issue date and the return date in the database. As you can see, we are changing the date in the screen. You can verify the dates that are changed in the database with the real-time date from the screen itself. Now we will go to the actual demo of the hardware. These are the barcodes that we will be using. The user places his hand in front of the return IR sensor. First of all, showing the book barcode that we want to return. As you can see it in the screen, the book has been detected. Now the user needs to place the user ID so that the system detects that the book has been returned by the user. As you can see it in the screen, the book has been returned by the user with find. You can also verify it in the database that the book has been returned. At the same time, you can see it in the user database that the user has been fined with ₹50. You can also check the email of the user, and the same has been sent to the email of the user. You can also add several modifications to this project and truly make it your own. For example, instead of using the serial monitor of the Arduino to send the data about the new user to the database, you can create a web page and connect it to the Arduino IDE, and then use the GUI created via the web page to send the data to the database. This will make the project much more appealing to the users. Another example would be adding more security features to the project. You can do that by introducing facial recognition features instead of using QR based user IDs. The facial recognition feature will make sure that no other user is returning the book that has been issued by another user. If you are having any issues or you have any query regarding the project, do not forget to comment below or contact me through GitHub. I'll be ready to help you with your own project too. At last, I hope that by watching this video, you are able to create your own automated library management system project. Thank you.